Hello student, today we'll talk about the frequency distribution. You all know that frequency distribution can be categorized into two ways. One is observed frequency distribution, which is always based on the actual observation and experimentation. And second one is theoretical or expected frequency distribution. And in this distribution, certain hypotheses, certain assumptions are always there. Theoretical distribution can be divided into three categories: binomial distribution, Poisson distribution, and normal distribution. Just to apprise you all, those who have just clicked this video and watching the normal distribution video, and if you don't know anything about binomial distribution and Poisson distribution, don't worry about it. It's completely new chapter, new phenomena, new philosophy. You will understand normal distribution after watching this series of videos on normal distribution 1, 2, 3 and on. But those who want to understand binomial distribution and Poisson distribution can watch my previous videos as well, which is available in this channel only. Moving to the next. What is the normal distribution? So the normal distribution is a continuous probability distribution based on continuous random variable, and it can be derived from the binomial distribution in the limiting case when n is sufficiently large or n is very large. So this n could tending to infinity. So point is what? Normal distribution when n is large and tending to infinity, and probability is close to half, near to 1 by 2 or 0.5. So then the normal distribution came into the existence. The general equation of normal distributions can be written as f of x equals to 1 upon sigma root 2 pi e to the power minus 1 by 2 x minus mu upon sigma whole square. Now there are various symbols. Hope you are wondering about. So let me introduce you the symbols. Sigma stand for standard deviation. This mu stand for the mean of the distribution. And maybe you are wondering about that what will be the value. So sigma could be the greater than 0. Mean, that is mu, could lies between minus infinity to plus infinity. And what is this x? So this x you can term as normal variate or normal variable. Alright? So this x can also assume the value from minus infinity to plus infinity. This pi everybody knows, so I am not going to say anything on it. So pi is 22 by 7 and 3.14 if you forget. And what is this f of x? So this f of x is used to say general equation of normal distribution, but more precisely you can see and say this one as probability distribution function, that is PDF. Fine? It's not printable documental file, right? It's probability distribution function. We have already discussed this thing, so skipping on that. And now if you can trace that curve f of x, what we have just seen, do you remember? 1 upon sigma root 2 pi e to the power minus half x minus mu upon sigma whole square. So that normal distribution function or general equation of normal distribution f of x, if you can trace it, you will find the curve like this, where mu is in between, and this spread are always defined with the help of sigma. So sigma, changing the sigma increases or decreases the spread, and changing the mu shift the distribution left or right. So what I want to say is that suppose you are shifting the mu to the left hand side, you might have the graph like this. So in that case mu will somewhere here, and similarly you can shift the mu and you can find out, you can shift the mu here and your curve will move like this. So changing the mu will shift the distribution left to the or right, and sigma will change the spread. So suppose we have the smaller sigma, so we could have that kind of curve. Suppose we have the bigger sigma, we could have that kind of curve. So this spread is basically defined by the normal distribution, and this parameter like mu and sigma we have already seen. This is one is your f of x PDF and pi and e, and suppose all with some notation or some calculation, e to the power minus half x minus mu upon sigma whole square. That means the exponent of anything whatever is here could be 1, then e is to the power 1 is what? So e to the power 1 can be 2.71828. And this is a bell-shaped curve with different center and spread depending upon mu and sigma. Normal PDF. What is that? So it looks that whatever the value of mu and sigma doesn't matter. If you can integrate, you will find it as 1. What it means? Have you heard about the probability? Yes, of course. So what is probability? Whether today will be rain or not? आज बारिश होगी कि नहीं होगी? That is what? P equals to 1 by 2, 50% probability. Right? If the normal temperature is there, P is equals to 1 by 2. Alright? Similarly, what will be the probability for no rain? So Q is also 1 by 2. And sum, if you want to find out the sum of the probability, you will find P plus Q equals to 1. So sum of all the probabilities are always equals to 1. When we talk about sum, it is the case of discrete random variable. But if we talk about the continuous random variable or the normal PDF, you could not sum it because we have the f of x, right? So you have to integrate it from the range of minus infinity to plus infinity, right? So minus infinity to plus infinity and f of x, the distribution is there, so it will be equals to 1. That's the claim, and don't worry, we'll discuss it in the coming videos. Entire group will also we will discuss in the coming videos, right? Let me introduce you another two concepts of the normal distribution as mean and standard deviation. So mean expectation of x is equals to mu, and how we'll define it? So it is minus infinity to plus infinity x times f of x. And what is f of x? We have already seen. So expectation of x, which is equals to mu, and it is minus infinity to plus infinity x times f of x dx. And now we'll define the variance of x. So variance of x can be defined as expectation of x square minus expectation of x whole square. So you can see that it is what expectation of ex whole square. It is looking like minus infinity to plus infinity x square f of x dx minus e of x we have just calculated as mu. So this one it is equals to minus mu square. And what is f of x? F of x is all this variable. Alright? So this is what the variance of. Variance is always represented by the sigma square, and standard deviation is represented by the sigma only, and it is always you can find out the square root of variance as well. Right? Now let me introduce you the beauty of normal curve. Here I have represented the beauty of normal curve with the tricolors blue, green and red. Let me introduce you the concept behind. So before going on to the concept, let's try to understand that it is basically a symmetrical curve. If you can say that this is what a x-axis and this is what a y-axis. So in the x-axis you can see that in between if you put 0 somewhere, right, so you can see that the same kind of feature is available to this side and same kind of feature is available to this side. And we have already agreed on one point, that is what minus infinity to plus infinity f of x dx equals to 1. And we have also agreed on this thing that the normal distribution curve, when you stretch it, it will have a two tail, left tail and right tail. It looks like that it is going to touch the x-axis, but it will never touch, and it will touch at minus infinity to plus infinity. And who has seen the minus infinity and plus infinity? Nowhere, right? So without ever meeting it, it looks like this. Okay, so minus infinity plus infinity f of x dx equals to 1. So in that way, my dear student, you can see one thing, that one calculation, that is what 0 to infinity f of x dx will be what? Can we guess? Yes, it's 0.5. And similarly, for minus infinity to 0, f of x dx will also be equals to 0.5. But that how we have calculated? That we have calculated with the notation of the symmetry of this side and that side. Alright? But there are few more things to understand. That is what, if mu and sigma, whatever the value, doesn't matter, mu minus sigma to mu plus sigma, if you integrate this one, you will get 68% of the area is covered by the red color. Mu minus 2 sigma to mu plus 2 sigma, if you can integrate this integration, minus mu minus 3 sigma, mu minus 2 sigma to mu plus 2 sigma f of x dx, you will get 95%. And similarly, mu minus 3 sigma to mu plus 3 sigma, you will get 99.7% of the data will be covered, right? So coming to this one, and here you can say that this part is 68%, this part is 95%, and this part is 99.7%. So if you can write down in terms of expression, let me write down in the next slide. Yeah, here. So you can see that mu minus sigma to mu plus sigma, it comes as 0.68%, 0.68 in fact, and we can represent it in terms of percentage. So this is what 68% data, right? This is what 95% of data, and this is what 99.7% data. Just imagine a case. Let's put mu equals to 0 and sigma equals to 1. What happened? This entire situation will change, like minus 1, 2 plus 1, right? And this all expression is what? This all expression is nothing but f of x. So f of x dx. So it will be equals to 68%. You got my point? And similarly, minus 2 to plus 2 f of x dx equals to 95%. And similarly, minus 3 to plus 3 f of x dx is 99.7%. So what the point I am going to make you, and what is the beauty of normal curve, that from the in the range of minus 3 to plus 3 only, you will find the entire spectra of the normal distribution, whatever the mu and whatever the sigma, doesn't matter, right? So this curve is going to touch at minus infinity, x-axis will be, and plus infinity, it will touch to the right hand side. But point is what? Suppose here we have a 0, and here we have 1, here we have 2, here we have 3. So this part, and here also we have minus 3, here also we have minus 2, and here we have, say, minus 1. So this part is 99.7%. And guys, 99.7%, if you can subtract it from 100, what you will get? You will get only 0.3. That is very small part. So you need not to go beyond the minus 3 and plus 3. That's my claim. And that's how the beauty of this normal distribution curve and the normal distribution story. So this story will continue, and please continue watching the next video on it, so that you can understand more on the normal distribution. Few more topics are there, then we have some practical example, and also we will learn how to see and how to use the normal distribution table or in the next slide, in the next video. Thank you very much for watching this one. Please do like and share if you like this video. Thank you very much.